A very good morning, class. I hope everybody is fine and doing e-learning and also enjoying it. As in our previous class, we have started with the second unit, that was force and laws of motion. In that, we discussed about the force, effects of force, and Newton's first law. As I've told you, there are three laws of Newton. First law we have discussed. What was that? A body at rest will remain at rest and a body in motion will continue in motion unless and until it is compelled by an external force to change its state of rest or of uniform motion. Today we will discuss the Newton's second law. But before I tell you about the Newton's second law, I want to tell you about a very important concept that is known as momentum. Momentum. We know that a cricket ball is much more heavier than a tennis ball. Suppose we throw a cricket ball and at both with the same speed and velocity. It will be found out that more force is required to stop a cricket ball because it has more mass, and less force will be required to stop a tennis ball which has less force. यहाँ से हम conclude करते हैं कि force required to stop a moving body is directly dependent upon its mass. Now, if we throw two cricket balls of the same mass at different speeds or velocities, it will be found that more force is required to stop the cricket ball, which is moving with higher velocity, and less force is required to stop the cricket ball moving with lesser velocity. मतलब जो बॉल ज़्यादा वेलोसिटी के साथ मूव कर रही है तो उस पर हमें ज़्यादा फोर्स लगानी पड़ेगी, और जो कम वेलोसिटी के साथ मूव कर रही है तो उसे रोकने के लिए हमें कम फोर्स अप्लाई पर करनी पड़ेगी. यहाँ से हम कंक्लूड करते हैं कि फोर्स वेलोसिटी पे डिपेंडेंट भी है और मास पर भी डिपेंडेंट है. अगर हम इन दोनों क्वांटिटी को कंबाइन करते हैं, दोनों का प्रोडक्ट लेते हैं, मास और वेलोसिटी, तो हमें बॉडी का मोमेंटम मिलता है. क्या मिलता है? मोमेंटम. So, the momentum of a body is defined as the product of mass and velocity. Momentum is equal to mass into velocity. Momentum is represented by small p, mass by m and velocity by v. So, its formula becomes p is equal to m into v. Now, let's come to the SI unit of it. We know that mass is measured in kilogram and velocity in meter per second. So, the SI unit of momentum becomes kilogram meter per second. Every moving body possesses momentum. Since the body is dependent upon the mass and velocity of a body, now we will discuss an everyday situation which involves the large momentum. We know that a karate player can break a pile of tiles or a slab of ice with a single blow of his hand. This is because the karate player strikes the piles of tiles or the slab of his hand very fast. In doing so, the large momentum of the fast-moving hand is reduced to zero in a very short time. उससे क्या होता है? It exerts a very large force on the pile of the tiles or the ice slab, which is sufficient to break it off. मीन्स हमने देखा होगा एक कराटे प्लेयर को एक स्लैब ऑफ टाइल्स दे देते हैं तो एक हैंड के ब्लो से उसे सडनली तोड़ देता है, क्योंकि इट कम्स विद अ वेरी लार्ज वेलोसिटी एंड अ सिंगल ब्लो व्हेन अ फोर्स इज अप्लाइड ऑन इट ब्रोक्स डाउन बिकॉज ऑफ द मोमेंटम. नाउ आई विल एक्सप्लेन यू द न्यूटन्स सेकेंड लॉ ऑफ मोशन. अकॉर्डिंग टू न्यूटन्स सेकेंड लॉ ऑफ मोशन, the rate of change of momentum of a body is directly proportional to the applied force and it takes place in the direction in which the force acts. इसका ये मतलब होता है the rate of change of momentum क्या होगा? अगर एक बॉडी के मोमेंटम में चेंज आ रहा है, मतलब फाइनल मोमेंटम माइनस इनिशियल मोमेंटम, that will be change in momentum. mv minus mu. mv is the final momentum and mu is the initial momentum. The rate of change in momentum of a body किसके डायरेक्टली प्रोपोर्शनल है? टू द अप्लाइड फोर्स. उस बॉडी के ऊपर जितनी फोर्स अप्लाई हो रही है वो उसके मोमेंटम के, चेंज इन मोमेंटम के डायरेक्टली प्रोपोर्शनल होता है, according to our Newton's second law. So force is directly proportional to change in momentum अपॉन टाइम टेकन. जितना टाइम लग रहा है उस मोमेंटम को चेंज होने के लिए. तो हम इसे ऐसे लिख सकते हैं, फोर्स इज डायरेक्टली प्रोपोर्शनल टू mv माइनस mu अपॉन t. अब m मास तो कॉमन है, हम इसे बाहर ले सकते हैं. m इज इक्वल टू v माइनस u अपॉन t. हमें पता है एक्सेलरेशन का फॉर्मूला क्या होता है, चेंज इन फाइनल वेलोसिटी माइनस इनिशियल वेलोसिटी अपॉन टाइम टेकन. So in place of v minus u upon t we can write a. तो अब ये फॉर्मूला क्या हो जाएगा, f is directly proportional to m into a. अब जब हम प्रोपोर्शनैलिटी का साइन जब भी हटाते हैं तो वी पुट अ कांस्टेंट k here, और इस कांस्टेंट की SI यूनिट में वैल्यू क्या होती है 1. तो अब फॉर्मूला क्या हो जाएगा, f is equal to k into m into a. k की वैल्यू क्या है 1. तो फाइनली वी गेट्स द फॉर्मूला force is equal to mass into acceleration through Newton's second law. So हम कह सकते हैं Newton's second law of motion gives us a relationship between force and acceleration. So force is directly proportional to the mass of the body and acceleration produced in the body. Now we will see the applications of Newton's second law of motion. Catching a cricket ball. A cricket player or a fielder moves his hands backward on catching a fast cricket ball. क्यों? This is done so to prevent the injury to his hand. Means एक fielder जब खड़ा होता है और बॉल बहुत तेजी से उसकी तरफ आती है, जो अपने हाथ क्या कर लेता है, वो नीचे कर लेता है, जिसकी वजह से उसके हैंड्स में चोट ना लगे. क्यों? A fast moving cricket ball has large momentum. In stopping or catching the cricket ball, its momentum has to be reduced to 0. Now the cricket player moves back his hand on catching the fast ball. Then the time taken to reduce the momentum of the ball to 0 is increased. Means जब वो अपने हाथ नीचे कर रहा है तो मोमेंटम में जो चेंज आ रहा है वो कम हो जा रहा है, और इसकी वजह से उसके हैंड्स पर चोट नहीं लगती है. One more example, the case of a high jumper. During an athlete's meet, a high jumping athlete is provided either a cushion or a heap of sand on the ground to fall upon. This is done to prevent the injury to the athlete when he falls down after making a high jump. क्यों? जब वो fall down करेगा, जब वो large heap लेकर आ रहा है, it will take a longer time to come to stop. This, the rate of change of momentum of the athlete is less due to smaller stopping force acting on the athlete, and the athlete does not get hurt. Thus, the cushion or the sand being soft reduces the athlete's momentum more gently, और जिसकी वजह से उसे चोट नहीं लगती है. Now we come to the Newton's third law of motion. This law is very easy. It states that whenever one body exerts a force on another body, the second body exerts an equal and opposite force on the first body. इसका मतलब ये है, to every action there is an equal and opposite reaction. Means अगर हम एक बॉडी के ऊपर फोर्स लगा रहे हैं तो वो दूसरी बॉडी भी पहली बॉडी के ऊपर फोर्स लगाती है. Means equal and opposite reaction is there. Let's see an example. Suppose a box is resting on the ground. The box is exerting a downward force of its weight on the ground. The downward weight of the box is balanced by an equal upward force supplied by the ground. Now we can say that the force exerted by the weight of the box is the action, and it acts on the ground, whereas the force exerted by the ground on the box is the reaction, and it acts on the box. मीन्स जो ऊपर से लग रही है और जो नीचे से, दोनों एक दूसरे को क्या कर रही हैं, आपस में बैलेंस कर रही हैं. तो इसका मतलब हुआ, टू एवरी एक्शन देयर इज एन इक्वल एंड अपोजिट रिएक्शन. नाउ वी विल सी सम एग्जांपल्स टू illustrate the Newton's third law of motion. First, how do we walk? When we walk on the ground, then our foot pushes the ground backward. हम चलते हैं तो ग्राउंड क्या करते हैं, हमारे फुट को बैकवर्ड पुश करता है. And in return, the ground pushes a foot forward. The forward reaction exerted by the ground on a foot makes us walk forward. इसका मतलब क्या हुआ? To every action there is an equal and opposite reaction. Force on foot is reaction and force on ground is the action. Let us discuss the swimmer now. A swimmer pushes the water backward with his hand and feet to move in the forward direction in water. It is equal and opposite reaction to the force which moves him forward. Means the push of the swimmer on the water and the push of water on the swimmer is the action. So to every action there is equal and opposite reaction. Why the gun recoils? We know that the force on the bullet applied is the action, and the force on a gun which moves our shoulder backward or a little jerk which we feel when the guns recoil is the reaction. To every action, again there is an equal and opposite reaction. One more example we will discuss, the flying of the jet aeroplanes and rocket. Jet aeroplane utilize the principle of action and reaction. In modern jet aircraft, the hot gases obtained by the rapid burning of the fuel rushes out of a jet at the rear end of the aircraft at greater speed. The equal and opposite reaction of the backward going gases pushes the aircraft in the forward direction. So, push of the engine on the gases is the action and the reaction is push of the gases on the engine. To every action there is an equal and opposite reaction.